Hello and welcome to Algebra 1 Lesson 5. In this video, we're going to learn about solving linear equations in one variable. Okay, so in the last two lessons, we've learned how to solve very simple versions of a linear equation in one variable. So we kind of started out by learning something known as the addition property of equality, and then we moved on to talk about the multiplication property of equality. But in this lesson, we're going to combine the two and learn how to solve any linear equation in one variable. So let me first define what a linear equation in one variable is. It looks like this, and you're probably going to see this in your textbook. AX plus B equals C. Now, in the previous two lessons, you probably heard me say that A, B, and C are real numbers. And we really haven't talked about what a real number is yet, but for right now, just think of it as any number that you can think of. So now let's kind of move further in this definition, and we're going to put a restriction on A. So that's this right here. So you see here where I have A does not equal 0. And why can't A be 0? Well, if I plug a 0 in for A, I would have 0 times x. And 0 times x is 0, so then I just have B equals C. And that's not going to work unless B and C are the same number, and in almost every case, they're not going to be. So, again, let me reiterate. AX plus B equals C is kind of our general form for a linear equation in one variable, where A, B, and C are real numbers, so any numbers that you can think about, and A can never be 0. So this can never be 0. All right, let's talk a little bit about the addition property of equality. Again, this tells us that we can add or subtract any number to, or in the case of subtraction from, both sides of an equation. And remember, we use it to solve these simple equations that look like this. X plus 4 equals 7, right? So in this case, we have 4 that's being added to x. We want to isolate x, so what we do is we subtract 4 from both sides of the equation, right? That's how we isolate x. Because we're adding 4 to x, we subtract 4, so x can be by itself, right? 4 plus negative 4, or 4 minus 4 is 0, and x plus 0 is just x. So I cancel this out here. This becomes a 0. And then over here, 7 minus 4 is 3. So let me scroll down a little bit, and we have x equals 3. And I taught you how to check things. We plug the 3 in for x in the original equation. You'd have 3 plus 4, which is 7. You'd have 7 equals 7. So that checks out. All right, so the other property that we've already talked about is the multiplication property of equality. Now this tells us that we can multiply or divide both sides of an equation by the same non-zero number. Okay, so you can't do it with 0, but anything else. So that's another example of a restriction. So we use this to solve stuff like 6x equals 36, right? So in this case, I'm multiplying x by 6. So to kind of undo that and to get x by itself, I'm going to divide, right? Just think about the opposite operation. If I'm adding something to x, I want to subtract. If I'm subtracting away from x, I want to add. If I'm multiplying something by x, I want to divide. If I'm dividing x by something, I want to multiply. So in this case, I am multiplying x by 6, so I want to divide by 6, right? And I have to do that to both sides of the equation to preserve the solution. So this cancels with this and becomes 1. 1x is just x. 36 divided by 6 is 6. And of course, if you want to check this, if I plugged a 6 in for x there, 6 times 6 is 36. You'd have 36 equals 36. So that is correct. Okay, so now that we kind of have the hang of the basics, let's talk about a general procedure for solving a linear equation in one variable. And this is for any linear equation that you run across. We're going to look in the next lesson at what to do when you have fractions or decimals. But even if you didn't use that, what we're going to cover in the next lesson, you can still solve it using this procedure. All right, so the first thing you want to do is simplify each side completely. Some of the things you're going to have to do, you are going to have to combine any like terms that you might have on each side. And you're also going to want to remove any parentheses that you have using the distributive property. All right, so the next thing you have to do is isolate the term that includes the variable on one side of the equation. So you're going to do this using the addition property of equality. So kind of think about it as, okay, I learned the addition property of equality first. That's always what I'm going to use first. All right, so the next thing we're going to do is isolate the variable, and you're going to do this using the multiplication property of equality. And remember, we learned this second, so this is kind of the next step that you do. So you do the addition property of equality first, then the next step you do is the multiplication property of equality. Now this is going to give you your solution, and then you just want to check the answer. All right, so let's take a look at -4 minus, we have 4 times the quantity, 5 plus 5x, and this is equal to -64. Now again, the first thing we want to do is simplify each side separately. So over here on the left, I have -4, and then for the sake of simplicity, let's write this as plus -4 times this quantity, 5 plus 5x. Because when I'm doing my multiplication here, I want to include the negative when I'm multiplying. And you don't have to write plus -4. You can just have a minus out in front of the 4 and just kind of include that in the sign, right? At this point in the game, you want to do things to kind of speed up your arithmetic. All right, then this equals -64. Nothing I can really do with -4 at this point. I'm just going to rewrite that. And then over here, I'm going to use my distributive property. So I'll multiply -4 times 5. That's -20. So we'll have plus -20, or of course you can write -20. Does not matter. And then I'm going to multiply by 5x now. So -4 times 5x would give me -20x. So I'm going to write -20x. Or of course, again, I could write plus -20x. Again, it doesn't matter. So then this equals -64. Now, I'm looking to combine any like terms that I have. I can't do anything with this because I don't have any other variable term involved in this equation, right? I just have that one. But over here, I have -4 plus -20. I can combine those two. So -4 plus -20 is -24. So this will be -24 minus 20x equals -64. Okay, so now I'm at the stage where I want to isolate the term that includes the variable. So that term is this right here, this -20x or -20x, however you want to think about that. So how do I isolate that? Well, we already know that we use the addition property of equality. And essentially, if I have this -24 over here, if I add 24 to both sides, I'm going to get rid of it. Right? So if I have -24, I add 24. If I was to come across positive 24, I would subtract 24, right? You always want to do the opposite. So I'm just going to add 24 over here. And then to make that legal, I'm going to add 24 to this side of the equation. Now this is going to cancel, right? -24 plus 24 is 0. So the left side of this equation is -20x. On the right side, I have -64 plus 24. So what's that going to be? Well, mentally, we can do this. We have a 4 and a 4 here. So really, I'm doing 64 minus 24, which is 40, and I'm slapping a negative on it. So this is going to be -40. Okay, so now we're at our third step. And remember, that's to isolate the variable. We do this using the multiplication property of equality. Now, if I have -20 times x, to get x by itself, I need to divide, right? Remember, this is multiplication. The opposite of that would be division. I need to divide by -20. Again, just look at what's being done to x. If -20 is multiplied by x, the opposite of multiplication is division. Okay, so if I'm multiplying -20 by x, I divide by -20 so that these two will cancel out and become 1, and I just have x by itself. Now, because I do it to this side, I must also do it to this side. And -40 divided by -20 would give me 2. So what I get as my solution is that x is equal to 2. All right. So we definitely want to check this and make sure we got the right answer. So let me erase everything, and we'll go back up to the top. All right. So we have x equals 2. We have -4. We have -4. Minus 4 times the quantity 5 plus 5, where I see the x, I'm going to plug in a 2. and then close the parentheses, and then equals negative 64. Okay, so let's crank this out. We're going to start out inside the parentheses here, and we're going to start out with 5 times 2. 5 times 2 is 10, and then if I add 10 to 5, I'd have 15. So I'll have negative 4 minus 4 times 15, and this should equal negative 64. So I'm going to do multiplication first. So you can think about this as negative 4 times positive 15. That would give me negative 60. So negative 4 minus 60 equals negative 64. And of course it does, right? Negative 4 minus 60 is negative 64. So we get negative 64 on the left. We have negative 64 on the right. And so yes, x equals 2 is the correct solution. All right, let's take a look at another one. We have negative 3 times the quantity, 5p minus 5 plus 2p equals 67. So again, the first thing I want to do is simplify each side separately. So to do that, over here, I'm going to use my distributive property. I'm going to multiply negative 3 times 5p, and that's going to give me negative 15p. And then next, I'm going to multiply negative 3 times negative 5. So negative 3 times negative 5 is positive 15. And then plus 2p equals 67. All right, now I want to combine any like terms that I have. So over here, I have negative 15p and I have 2p. So negative 15 plus 2 is negative 13. The variable comes along for the ride. So this is negative 13p plus 15 equals 67. There's nothing else to simplify on each side. And so now I move on to the next step where I'm going to isolate the variable term on one side of the equation. Now, if I look at my variable term, it's negative 13p. What's being done to it? Well, I'm adding this 15 right here. So in order to isolate negative 13p, I need to do the opposite operation. I need to subtract 15 away. Or you can think about it as adding negative 15 to both sides, right? So I need to subtract 15 over here, and then over here to make it legal, I need to also subtract 15. So this is going to cancel and become 0. And I have isolated my variable term on one side, so I have negative 13p here. And then over here, 67 minus 15, that's going to give me 52, right? 7 minus 5 is 2. 6 minus 1 is 5. All right. So now what's left, we want to isolate the variable, right? So we want to isolate p. And how do we do that? Well, we always want to look at what's being done to that variable, right? So in this case, we have negative 13 that's multiplying our variable p. So to undo multiplication, we do division, right? So we're going to divide both sides of the equation by the coefficient of p, which is negative 13. Very, very simple. So this cancels with this, and I'm just going to have p. And then over here, what is 52 divided by negative 13? Well, it's going to give me negative 4. And that's my solution. P is going to equal negative 4. All right, let me erase everything, and then we're going to go back and check. All right, so let's see if we got the right answer. We're going to have negative 3 times, inside the parentheses, we have 5, plug in a negative 4 for p, so times negative 4, minus 5, close the parentheses, plus 2 times negative 4 equals 67. So we're going to start out inside the parentheses here. We always multiply first. 5 times negative 4 is negative 20. Negative 20 minus 5 is negative 25. So this would be negative 3 times negative 25 plus, we have 2 times negative 4 equals 67. So we're going to multiply before we add. Negative 3 times negative 25 is 75. Plus, we have 2 times negative 4, that's negative 8. And this equals 67. All right, so what is 75 plus negative 8, or what is 75 minus 8? Well, that's going to be 67. So we have 67 equals 67. And so p equals negative 4 is the correct solution. All right, let's take a look at another one. We have 30 equals negative 10 times the quantity 9x plus 10 plus 8 times the quantity negative 5 minus 10x. So again, I want to simplify each side separately. So I have 30 on the left. Nothing I can really do with that. On the right, I'm going to use my distributive property. And I'm going to multiply negative 10 times 9x. So that's going to be negative 90x. Plus, I'm going to have negative 10 times positive 10, which is negative 100. So I can write plus negative 100. I could just write minus 100. So then plus, now we have 8 times negative 5. That's going to be negative 40. So I'm just going to write minus 40. And then we have 8 times negative 10x, and that's going to be negative 80x. All right. So now we want to combine like terms. And basically, you can see that we have negative 90x and we have negative 80x. Those can be combined. And we also have negative 100 and we have negative 40. Those can be combined as well. So we have 30 on the left. That's not changing. On the right, negative 90x minus 80x, or negative 90x plus negative 80x, however you want to think about that. That's going to give me negative 170x. Then I'm going to have negative 100 minus 40. That's minus 140. So now that we've simplified each side completely, meaning I can't do anything else to either side to make it more simple, I'm going to isolate the variable term. So in this case, that's going to be this right here, this negative 170x. Now, again, what can we do here to isolate that? We have to look at what's being done to the variable term. I'm subtracting away 140. So if I'm subtracting away 140, again, always look to add the opposite. So the opposite of negative 140 is positive 140. And I got to do it to both sides to make this legal. So that cancels, becomes 0. 30 plus 140 is 170. So this equals over here just negative 170x. And to get x by itself, to isolate the variable, which is our next step, we look at what's being done to x. And in this case, we have multiplication. So again, you always look to do the opposite. If you're multiplying, you divide. If you're dividing, you multiply. If you're adding, you subtract. So it's just that simple. So in this case, we have multiplication, so we look to division. So divide this by the coefficient of x, which is negative 170. Divide this by negative 170. So this and this are going to cancel and become 1. 1 times x is just x. And then over here, 170 divided by negative 170 is negative 1. So you have negative 1 equals x, or you can flip that. A lot of people like to have the variable on the left, myself included. So if I see something like this, I just kind of flip it and say, okay, well, x equals negative 1. It doesn't really matter. These two mean the exact same thing, right? It does not matter whatsoever. All right, so let's erase everything and check our answer. All right, so we have 30 equals negative 10 times this quantity, 9 times negative 1 plus 10, then plus 8 times negative 5 minus 10 times negative 1, and then close parentheses. Okay, so we have 30 over here on the left, and then equals. Inside the parentheses here, 9 times negative 1 is negative 9. Negative 9 plus 10 is 1. So I would have negative 10 times 1, which is just negative 10, right? We don't even need to kind of write that. Then plus, we have 8 times, and then we have inside of here, negative 5 minus 10 times negative 1. So I can just think about this as negative 10 times negative 1. That's going to be positive 10. So negative 5 plus 10 would be 5. So I'd have 8 times 5 here. Now, in this next step, I would do my multiplication. 8 times 5 is 40. And so now negative 10 plus 40 would be 30. So I'd have 30 equals 30. And so my solution, x equals negative 1, is correct. Okay, let's take a look at one final problem. So we have negative 10 times the quantity negative 4 minus 6x. This is equal to 3 times the quantity negative 3x minus 8, then plus 5x. All right. So we're going to start by, again, simplifying each side separately. So on the left, negative 10 times negative 4 is 40. Then negative 10 times, think about this as negative 6x. That's going to be plus 60x. And this equals, over here, 3 times negative 3x is negative 9x. And then 3 times negative 8 is negative 24. So minus 24 plus 5x. Okay. So now I want to combine like terms. Nothing I can combine on the left. On the right, I can combine the negative 9x and the 5x. That's going to give me negative 4x. So I'm going to write this as 40 plus 60x equals, again, this will be negative 4x when I add negative 9x and 5x minus 24. All right, so I want all the variable terms on one side of the equation. That's how I kind of isolate the variable term on one side and I have just a number on the other. So in the previous examples, it's been kind of easy to do that. Here, what you're going to notice is that you have a variable term here and here. Now, what you want to do is use the addition property of equality to get both on one side. Remember, I can move anything. So if I have negative 4x over here, I can just add 4x and make it disappear on this side, but I have to do the same thing over here to make it legal. So in other words, if I add 4x here, it's going to disappear on this side. Negative 4x plus 4x, that's 0. So it's gone. But it reappears over here because I have to also do it on this side to make it legal. So now I'll have 40 plus 60x plus 4x is 64x, and this equals negative 24. This is still not what I want because I want a variable term on one side of the equation, and I want just a number on the other. So in order to do this, again, if I'm adding 40 to the variable term 64x, to make this 40 go away, I'm just going to subtract it away, right? But I have to do it to both sides. That's the key. So minus 40 over here and minus 40 over here. So now this is gone, and I just have 64x. 64x on the left side, so I've isolated the variable term. On the right side, negative 24 minus 40 is negative 64. Now I just want my variable by itself, so I just want x. So how am I going to get that? Again, look at what's being done to x. If we're multiplying, like we are here, you have 64 that's multiplying x, so you want to use division, right, to undo the multiplication. So if I divide both sides of the equation by the coefficient of x, which is 64, I'm going to get x by itself. This cancels with this. Remember, 64 divided by 64 is 1. 1 times x is just x. Over here, negative 64 divided by 64, this gives me negative 1. So negative 1, x equals negative 1 is my solution. All right, so let's erase everything and check. And so we'd have negative 10 times this quantity, negative 4, minus 6 times negative 1. This equals 3 times this quantity, negative 3 times negative 1, minus 8, then plus 5 times negative 1. And again, all I'm doing is I'm plugging in a negative 1 everywhere that x exists. So that means I plugged in a negative 1 here, here, and here. And I'm just going to make sure the left and the right side are going to be the same value, right? Make sure they're equal. So on the left, I start inside the parentheses, and I'm going to start with negative 6 times negative 1. That's 6. And so I'd have negative 4 plus 6. That's going to give me 2. So this left side would be negative 10 times 2. On the right side, inside the parentheses, negative 3 times negative 1 is 3. 3 minus 8 is negative 5. So I'd have 3 times negative 5. And then plus 5 times negative 1. Let's do all our multiplication. Negative 10 times 2 is negative 20. 3 times negative 5 is negative 15. And plus 5 times negative 1 is negative 5. You can kind of eyeball this and see it works out. On the left, you have negative 20. On the right, negative 15 plus negative 5 is negative 20. And so negative 20 equals negative 20. We have the same value on each side of the equation, so we know that x equals negative 1 is the correct solution.